That's a good question. Confidential computing has sort of quietly become one of the linchpins of, modern, data security. Yet, most people barely understand or notice it. Imagine a world where, your most sensitive information, things like your medical records or financial data or data that's being used to train an AI model or prompts, you know, having those be encrypted, not just in transit and in rest, but also have them only accessible inside of a portion of the CPU and GPU that enforce, very strict security protocols such that not even the operating system can see the data. That is what confidential computing delivers. It really protects the data, even while it's being used. And it really helps get around, what I guess maybe is a hidden vulnerability of normal sort of in transit and at rest data security policies, which is at some moment you're decrypting that data and you're using it. And what is to say that the operating system or the hypervisor or other things on that system might not be accessing the memory, where that data is decrypted, and that is where insiders or hackers or misconfigurations can strike and become a problem. What is confidential computing and how does it solve it? Confidential computing creates a tamper-proof enclave inside both the CPU and the GPU, where your data remains encrypted even while it's being sort of used. And enclaves have four defining sort of security properties that enable them to do this. The first is isolation. The enclave is strongly isolated from the rest of your entire system. Nothing other than the CPU can look inside of an enclave, not the operating system, not the hypervisor, or any other part of the system. Second, enclaves have runtime memory encryption. Everything in the enclave is always encrypted in memory. The third thing that an enclave does is it seals. It allows that state of that enclave to be stored and restored on an otherwise untrusted system. And the last and sort of one of the more interesting and exciting parts is remote attestation. The enclave has the ability to convince a remote party that the enclave is secure and running on secure hardware. So, these are available in hardware technologies like Intel SGX and AMD SEV, and NVIDIA even has confidential virtual machines or CVMs inside of their data center scale processors like the H200 and the B200 and the NVL72. So when you pair those data center grade GPUs with a CPU that support enclaves, that allows data to be encrypted from end to end, from CPU to the GPU memory, all using hardware-enforced memory isolation. The GPU supports secure boot and firmware integrity, and encrypted memory to protect the models during inference and or training. Combine that with software like NVIDIA's confidential computing stack or Coco, which are confidential containers. And these GPUs enable secure AI workloads to work in an untrusted environment without exposing sensitive data or model weights to anyone. So for highly regulated sectors, this isn't optional. It's really essential. If you're thinking about healthcare, whether you're training or running a model, and you need to keep data confidential due to HIPAA, if you're processing government data under FedRAMP, if you're in finance and you're doing back testing of algorithms with financial models that are secure, you're just going to want to use confidential computing. Now, the trick has been turning this vision into reality has been difficult. Hardware configuration, kernel patches, operating system configuration, software setup, remote attestation servers, and compliance. It's all difficult to do, and it's a lot of work to get it running end to end. But, this need for secure data and computation is only increasing. So, in essence, confidential computing is going to create sort of large synergies between AI and security. So, we're going to unlock these powerful advantages of end-to-end, data and model encryption between the CPU and the GPU. And, customers that have invested, proprietary models, millions and millions of dollars, and training on sensitive data, now we have the ability to protect these things as long, as well as the prompts, the data that you're sending in via RAG, it's all protected. In summary, with confidential compute, you're able to encrypt model weights before they leave your environment as a trainer. You're able to stream sensitive data sets and prompts directly into GPU accelerated enclaves and make sure that this data is, maintained security without sacrificing efficiency throughout your entire pipeline. And this is the future. So, at Corvex, we run a large number of confidential computing workloads today on our cluster. We're here to help you, do everything from understand how this technology can impact you and your business, all the way up through getting it running successfully, for your specific scenarios.